Hello everyone. Great to see you again. Let me start with something fun. Imagine you and your best friend are walking from your home to the ice cream shop. Now, your mom says, "Stop exactly 1/3 of the way to the shop and wait for me." Where exactly will you stand? This is exactly the kind of problem the section formula solves. In coordinate geometry, we don't run around with a measuring tape, we calculate. For example, suppose town A is at 0, 0 and town B is at 36, 15. A telecom company wants to put a relay tower 1/3 of the way from A to B. By applying some geometry magic, we find the tower must be at 12, 5. Isn't that neat? Let's see how to generalize this idea. Alright, now let's derive the universal formula. Picture a line up with A at x1, y1 and B at x2, y2. A point P sits somewhere between them, dividing up in the ratio m1 is to m2. Here's the trick, draw a few parallels and perpendiculars and you'll notice similar triangles. Just like stacking Lego blocks in the same proportion, triangles scale in the same ratio. From that similarity, we can say Pa upon PB equals AQ upon PC equals PQ upon BC. When we substitute, AQ becomes x minus x1, PC is x2 minus x, PQ is y minus y1, and BC is y2 minus y. Now, equating ratios and solving step by step, we get x equals m1 times x2 plus m2 times x1 all over m1 plus m2. Similarly, y equals m1 times y2 plus m2 times y1 all over m1 plus m2. The section formula. One single neat formula to locate that point precisely. Let's take a special case, the midpoint. Imagine two friends want to meet halfway between their houses. Where do they meet? Exactly at the average of their locations. So if A is at x1, y1 and B is at x2, y2, then midpoint M is at open bracket x1 plus x2 over 2, y1 plus y2 over 2 close bracket. This midpoint formula is simply the section formula with ratio 1:1. And believe me, it comes up everywhere, geometry proofs, computer graphics, even in GPS when your app says, "Meet halfway at this cafe." Let's test the formula with an example. Suppose we want the point that divides the line from 4, -3 to 8, 5 in the ratio 3:1. Plugging into the formula, x equals open bracket 3 times 8 plus 1 times 4 close bracket over 4, which gives 7. Y equals open bracket 3 times 5 plus 1 times -3 close bracket over 4, which gives 3. So the point is 7, 3. Simple, quick, and no measuring. Just imagine, one person walks 3 steps while the other only 1 step. The ratio is perfectly respected. Now, let's flip it. Suppose you find a point already sitting on up, say -4, 6, between A at -6, 10 and B at 3, -8. Question, in what ratio is it dividing? Let's assume ratio m1 is to m2. For the x-coordinate, -4 equals m1 times 3 plus m2 times -6 over m1 plus m2. Solving carefully, we get 7 m1 equals to m2, so the ratio is 2:7. It's like sharing a pizza unevenly, 2 slices to one friend and 7 slices to another. And yes, if we check with the y-coordinate, the math agrees perfectly. Time for something juicier, trisection. Suppose A is at 2, -2 and B is at -7, 4. We need points P and Q that divide up into 3 equal parts. For P, ratio is 1:2. Plugging in, x becomes -1, y becomes 0. For Q, ratio is 2:1, giving x as -4 and y as 2. So the trisection points are -1, 0 and -4, 2. Just like cutting a chocolate bar into 3 equal pieces, math ensures each piece is fair. Where does all this come in handy? Everywhere. In parallelograms, we use it to show diagonals bisect. In triangles, extended ideas lead us to centroids. In exam questions, it helps prove collinearity or to locate where a line cuts an axis. Even in real life, imagine marking equal distances on a running track, placing flags at fractions of total distance, or programming a GPS app to show midpoints. Behind the scenes, it's the section formula doing the work. So let's recap. The section formula tells us if a point divides up in ratio m1 is to m2, its coordinates are open bracket m1x2 plus m2x1 over m1 plus m2, comma m1y2 plus m2y1 over m1 plus m2 close bracket. We saw the midpoint as a special case. We solved problems where we calculated points, back-calculated ratios, and even trisected a line. The beauty is that algebra and geometry join hands here. With just a little formula, we can locate any point along a segment, no ruler required. And that's the magic of the section formula. In our next video, we'll take this forward to explore areas of triangles using coordinates. Until then, keep exploring and enjoy the patterns that mathematics offers.